In this video lesson, our objectives today are to find molar mass and define what it is, then use it to convert from moles to mass and mass to moles, therefore making our second conversion. Before we start, I'd like you to take a look at these two pictures. What is the same between them and what is different? Let's first talk about similarities. The most obvious similarity that you most likely saw is that you have a dozen of each item. You have a dozen donuts and you have a dozen eggs, equaling 12. Now, you might be able to think that they're both edible, they're both in containers, and so on. But this is probably the one we're really concerned with the most, that there's the same quantity of both. Now let's think about what is different. Well, you might think color is different, taste is different, and so on. But let's focus on what we might be able to measure. Well, we can measure their mass. We could measure that they have different volumes. We could measure, if we had the proper tools, their composition, and so on. Hopefully what we're seeing is that though they have the same quantity, that does not necessarily mean that they have the other same characteristics. For instance, let's take a look at the first one, mass. Imagine you were in the lab and you could mass the donuts and the eggs. Would you expect their masses to be the same or to be different? Most likely you'd expect them to be different. A dozen donuts would not weigh the same as a dozen eggs. In the same way, 1 mole of one substance is not going to weigh the same as another substance. This is where molar mass comes into play. Molar mass is how much a substance or compound weighs for every 1 mole. Obviously, just like our donuts and our egg situation, it's always going to be different. We're going to take a look at two compounds and determine how to find molar mass. Let's first look at water. Water is a very common compound that we're going to be looking at. Let's go ahead and figure out what is the molar mass of water. In order to do that, you need to first list the elements that are involved in the compound. We have hydrogen and we have oxygen. The next step is we need to determine what are the atomic masses of each of those elements. That is found on your periodic table. Locate hydrogen on your periodic table. What is the atomic mass? The atomic mass is approximately 1.01. Notice that I go to 2 decimal places. From here on out, that will be my standard practice. Let's find oxygen. Oxygen's atomic mass is 15.9994. If we try to round that to 2 decimal places, it would be proper to round that up to 16. Now that we know the atomic mass for each of those, now we need to multiply them by how many atoms we have of each element. For hydrogen, how many atoms do you have? You have 2, so we multiply that by 2. For oxygen, we have 1, so we multiply that by 1. 1.01 times 2 will give you 2.02, and 16 times 1 will give you 16. The last step is you add these masses together. In this case, the molar mass for water is 18.02. Now let's think about our units. Water weighs 18.02 grams. It's not just grams, we have to relate that to an amount. Remember, it's molar mass, so it's telling us how much something weighs per mole. So the units for molar mass is grams per mole. This means that for every 1 mole of water that you have, it's going to weigh 18.02 grams. Now that's water. Let's take a look at another example. Suppose I give you this compound, magnesium nitrate. First step, write out our elements. We have Mg, we have nitrogen, and we have oxygen. The molar mass for magnesium is 24.31. The molar mass for nitrogen is 14.01, and the molar mass for oxygen is still 16. Next, we multiply by how many atoms we have. We have 1 atom of magnesium, keeping it at 24.31. Now, nitrogen and oxygen are inside of parentheses. Notice this 2 on the outside. The 2 distributes in to every part of the parentheses. So how many nitrogens do we have? We have 2 nitrogens, making a total mass for nitrogen 28.02. For oxygen, we have 2 times 3, giving us 6 total oxygens. 16 times 6 is 96. Our last step is to determine the total. We take 24.31 plus 28.02 plus 96 to give us a grand total of a molar mass of 148.33 grams per mole. Now notice, the molar mass for water was 18.02 grams per mole, whereas the molar mass for magnesium nitrate was 148.33 grams per mole. Quite a significant difference. Notice how you can have the same amount of both, meaning 1 mole, but not weigh the same. Water weighs considerably less than magnesium nitrate. In the same way, the mass of a dozen donuts and a dozen eggs does not weigh the same. Take a moment right now, pause the video, and determine what the molar mass is for the following compounds. Then, when you're ready, hit play to reveal the answers. For NaCl, your total molar mass approximately should be 58.44 grams per mole. For methane, CH4, the molar mass should be approximately 16.05 grams per mole. And the molar mass for aluminum carbonate approximately should be 233.99 grams per mole. Now that we understand what molar mass is and how to determine it, we can now use this in our conversions. First, we're going to consider going from mass to moles. Let's say I give you 32.5 grams of H2O, and I ask you to convert that to moles of H2O. In this case, we write out what we're given, which is 32.5 grams. We need to convert out of grams, and therefore it goes on the bottom. Moles is what we're trying to go to. That goes on top. Now our conversion here is different than before. With moles to particles, we used Avogadro's number, but that is not the case here. We're trying to find a relationship between moles and grams, which is a mass. We just learned that 1 mole of a substance weighs differently depending on its molar mass. Do you remember what the molar mass is of water? If not, determine that now. 2 hydrogens plus 1 oxygen. The molar mass for water is 18.02 grams for every 1 mole. The grams cancels out, and now we just solve. To determine the answer, we take 32.5, and we divide that by the molar mass, which is 18.02. Our number of moles with correct significant figures is 1.80 moles. That's going from mass to moles. Let's go ahead and try another way. Let's go moles to mass. Suppose I tell you that you have 2.7 moles of methane, CH4, and I ask you to convert that into grams. Since we want to get rid of moles, we know that moles then has to go on the bottom. And we're trying to get to grams, which goes on top. Once again, we're looking at a relationship between grams and moles, which we just learned was molar mass. For every 1 mole of CH4, it is going to weigh a certain amount. That is the molar mass. Take the molar mass of CH4 and plug that into the top. 1 carbon and 4 hydrogens together make a molar mass of 16.05 grams for every 1 mole. At this point, your moles cancels out, and now you are in grams. Now all we have to do is the math. We do 2.7 times molar mass being 16.05. Our answer with the correct significant figures is 43 grams of methane. This concludes the video lesson on moles to mass and mass to moles.